Okay, ready for this. Imagine like every time you make a decision, a whole new universe pops up.
Whoa.
It's a lot to think about, right? Like a cosmic choose your own adventure. But that's kind of what we're looking at today, quantum entanglement.
Mm,
And is there a link to like parallel universes? You sent over this amazing podcast transcript all about quantum physics.
right.
So let's get into it, pull out the good stuff, and see what we can learn.
Okay.
We're going deep into quantum mechanics here.
See.
But don't worry, we're going to keep it, understandable. Really try to focus on like the what
The what?
and then the so what. For everyone listening, what's in it for them?
Exactly. And this is one of those topics that really, I think it pushes us to think about like how much we actually know about reality.
Right.
Like where does physics stop and then philosophy begins? I mean, entanglement really makes us question, the very nature of existence.
Absolutely. And this all starts with this idea, this phenomenon called quantum entanglement, which honestly is so strange it even baffled Einstein.
Yeah. Think about that.
You know that spooky action at a distance quote?
Oh, yeah.
That was Einstein, right? That was him trying to wrap his head around what entanglement means.
And you can understand his skepticism because like entanglement basically says that two particles,
All right.
even if they're light years away, are connected. They're linked. And what happens to one, boom, it instantly affects the other.
No delay.
No delay. It's instantaneous.
Right.
So you can think of it like two coins, right?
Okay.
It doesn't matter how far apart you flip them. They always land on the same side.
Okay.
That's entanglement, but at the subatomic level.
So it's not just that, we don't know what side the coin's going to land on until we look at it.
Right.
It's like the act of looking at one coin
Yes.
somehow makes the other coin, wherever it is, maybe across the universe, land on the same side.
Exactly.
That just like breaks everything we think we know about cause and effect, right?
It does. And to kind of grasp why entanglement is so strange, I think we need to touch on like a few key concepts from quantum mechanics. So think about superposition.
Superposition.
The idea that like a quantum particle can exist in multiple states at the same time.
At the same time.
Yeah, until we measure it, until we look. So it's like Schrodinger's cat.
Right, the cat.
Both alive and dead until we open the box.
So particles are like the cat. They're not just like we're uncertain. It's that they're actually in multiple states at the same time.
Exactly. And that's where entanglement gets really, really interesting. Imagine you've got two of these, I don't know what to call them, superpositioned particles.
Okay.
And they're interacting. Then they separate. Even across these vast distances, their states are linked. When you measure one, and it collapses into one state, its entangled partner instantly collapses to a corresponding state.
No matter how far away.
No matter how far away.
So does that mean like our observation is not just passive, like we're actually influencing reality on like a quantum level?
Yeah.
It's almost like the act of measuring something is actually like shaping the outcome.
That's a great question. And that's what entanglement really makes us think about, Like, does that mean our consciousness is somehow shaping reality? And the coolest thing is that it's not just, these theoretical musings. It's actually been proven through experiments.
Oh, wow.
Back in the 1960s, John Bell, he came up with this theorem to test whether this spooky action, was actually real.
Okay.
And experiment after experiment has shown that Bell's theorem is true. Entanglement really does break our classical understanding of cause and effect.
It just like blows my mind to think that something we do here could instantly impact something on the other side of the universe.
I know.
It's like some cosmic secret language.
Yeah.
Operating beyond anything we can see or feel or even really imagine.
Beyond space and time. And it leads to one of the most mind-boggling implications of entanglement. The possibility of parallel universes.
Ooh, okay, let's get into that. Parallel universes.
Yeah.
Is this like, like the multiverse, like in the movies and sci-fi?
Well, not exactly like the movies, but there are some interesting parallels.
Okay.
One way of interpreting quantum mechanics, this is called the many worlds interpretation, suggests that like every single time a quantum event happens, like a particle choosing its state, the universe splits. Yeah, it creates a branch for each possible outcome.
So every decision, every event could be creating new universes.
Possibly, yeah.
I mean, if that's true, what does that even mean for like the significance of our actions in this universe?
Right.
Does it matter if I choose to go left or right? If infinite versions of me are making every other possible choice in these other universes?
Yeah, I mean, it's a mind-boggling concept.
It really is.
And it challenges how we think about reality and free will and even our own identity. And this is where entanglement comes back in. Some physicists believe it could actually be like a bridge between these parallel worlds.
Wait, are you saying our actions here could be influencing particles in other universes through entanglement?
Yeah, that's the hypothesis.
That's a lot.
Yeah, no, it's definitely speculative,
Hmm.
but it shows you just how deep this rabbit hole goes, you know? It's not just about particles, it's about the nature of reality and how we fit into it.
So while we're, pondering all these big questions,
Right.
is there anything more concrete that entanglement can do for us here in our own universe? Now, I keep hearing about quantum computing. Can you break that down for us? Like, what is it and why is everyone so excited about it?
Absolutely. I mean, even if we put aside, all the mind-bending theoretical stuff, entanglement has real-world applications that are honestly already starting to change the world. Quantum computing is a great example. Classic computers, they use bits, zeros and ones.
Right, binary.
Quantum computers use qubits, which can be in both states at the same time thanks to superposition.
Both at the same time.
Yeah. And entanglement allows these qubits to be connected, so they form this network, right, where they can work together in ways that normal computers just can't.
So we're not just talking about like faster computers, we're talking about like a completely different way of processing information.
Exactly. That's the game changer.
Wow.
So this means quantum computers can tackle these insanely complex problems exponentially faster than our old computers.
So give me an example. What kind of problems?
Imagine simulating how molecules interact at the atomic level to design new medicines.
Okay.
Or create, materials with properties we've never even seen before. It's going to transform fields like medicine, material science, even artificial intelligence.
So it's not just theoretical. There are real benefits to this.
It's already happening. Yeah, we're seeing breakthroughs in drug discovery, materials science, and even AI algorithms. It's like a technological revolution. It's starting right now.
That's incredible. But, with great power comes great responsibility, right?
Yeah.
We were talking about cybersecurity before. Are there any downsides to this kind of technology?
You're right. It's not all good. Quantum computers, they could potentially crack the encryption we use today. I mean, that's everything from online banking to national security.
Yeah.
So this could make sensitive data, vulnerable to attacks from all kinds of bad actors, individuals, even nation states.
So double-edged sword, it sounds like.
Definitely.
Quantum computing could solve some of the world's biggest problems, but it could also create a lot of new ones if we're not careful. It seems like we need to be thinking about the ethics of all this right now.
100%. I completely agree. We need to be having these conversations today. As this technology develops, we need to make sure quantum computing is used ethically and for the benefit of everyone.
Like, what kind of ethical guidelines do we need to think about?
Well, we need to think about the implications of things like autonomous weapon systems, advanced surveillance technologies that could erode our privacy, and even the potential for, existing inequalities to be made worse.
Right.
We need to be proactive about these things.
We're at the beginning of a brand new era.
We are.
And we need to be really careful about how we move forward. Okay, one more question about the practical stuff.
Okay.
What about quantum teleportation? Is that like a real thing, or is that just science fiction?
It's real, but it's not exactly like what you see in the movies.
Yeah.
Beaming people up.
Right, Star Trek.
It's not about transporting matter. It's about transferring information. So you can think of it as sending a blueprint.
A blueprint.
Of a particle state to another location, instantly.
Okay.
Without moving the particle itself.
So no beaming up, but we are getting better at transmitting data.
Yep.
What are the big implications of that?
Huge implications, especially for communication and computing. Imagine a world with instant, secure communication that can't be hacked.
Wow.
Because any attempt to, intercept the message would disrupt the entanglement.
Oh, interesting.
And alert the sender and the receiver. Or think about networks of quantum computers, right? All connected across huge distances, basically a quantum internet.
A quantum internet.
That's where this could lead.
That sounds so futuristic.
It is.
It's really exciting. But also, I can't help but think about the downsides. Instant, unhackable communication. I mean, there are a lot of questions about privacy and power.
Right, we have to be careful.
Who controls the information?
It's crucial to have these conversations now. As the technology is being developed, we have to make sure we're using this stuff ethically and responsibly. It's not just about the science. It's about the impact on society and making sure these advancements are good for humanity.
It's a lot to consider. But amidst all the technical details and the potential risks, I think it's also important to remember, like, the wonder of all this.
I agree.
The awe.
Absolutely. Quantum entanglement is like this profound reminder that reality is way stranger and more interconnected than we usually think about, It pushes us to kind of expand our minds, embrace what we don't know, and even question like our basic assumptions about what exists.
It's like we're peeking behind the curtain of the universe.
Yeah.
Seeing how it all works, the connections that we never even knew were there.
And I think that sense of wonder is crucial.
Yeah.
It's what drives us to explore, to learn, to push the limits of what we know as humans. It's what makes this whole journey so exciting, so worthwhile.
Well said. I think we've covered a lot of ground in this deep dive so far, from how these particles act to the implications of parallel universes.
Right.
We've talked about the potential of quantum computing, teleportation, the good, the bad, the ethical challenges. But we're not done yet. There's still more to explore, so stay tuned for part 2 of our deep dive into quantum entanglement.
Welcome back to our deep dive. Before we move on, I think it's worth going back to those philosophical questions that entanglement brings up.
Yeah.
Particularly like what it means for our understanding of consciousness.
That was a fascinating thread we kind of started pulling on before.
It was.
It's just wild to think that something as, intangible as consciousness could be linked to this quantum world.
Right.
So, like, what are some of the current theories about how those two things might be connected?
Well, some physicists and philosophers, they actually think that consciousness itself might be a quantum phenomenon.
Okay.
They suggest that the brain, could actually use quantum effects.
The brain.
Like superposition and entanglement.
Yeah.
To process information in ways that, honestly, we just don't understand with, like, our current knowledge of neurobiology.
So are we saying that our brains could be like biological quantum computers?
It could be. It's definitely a really compelling idea.
That's mind-blowing.
I know, and it's being explored by researchers, at the forefront of quantum physics and neuroscience. It's pretty cool.
Wow.
And there's also this idea that our minds could be entangled with the universe.
Okay.
In like a much broader sense.
Broader sense.
So remember how entanglement shows us that connections can exist across like vast distances?
Right. Instantly.
Instantly, yeah. So what if our consciousness isn't just limited to our brains? What if it's somehow connected to the fabric of reality itself?
There's almost like challenging our whole idea of what it means to be an individual, right?
Right.
If our minds are entangled with the universe, does that mean the lines between, the self and the observer and the observed, they all get blurry?
Yeah, definitely raises some deep questions about like the nature of identity and where the self ends and the rest of the world begins, And it touches on another age-old question, free will.
Free will.
If our actions are influenced by quantum entanglement in some way, does that mean we're not really making our own choices?
Right.
Are we just puppets, dancing along to some cosmic symphony?
It's a lot to wrap your head around, but it's just so fascinating to consider.
Yes.
It's like this one phenomenon, quantum entanglement, opens up so many doors to understanding not just the physical universe, but our place in it.
I think that's a great way to put it.
And while we're like contemplating all these deep philosophical questions, I think it's important to remember this is all still very much like speculation.
Yeah.
Exploration. We've got a lot more to learn about quantum mechanics and about consciousness before we can say anything definitive.
Right. But the exploration is the fun part.
It is.
And, while we're thinking about these big questions, speaking of wonder, there's one more aspect of entanglement we haven't talked about yet.
Oh, okay.
Quantum teleportation.
Quantum teleportation. It sounds straight out of Star Trek.
It does, but I mentioned before, it's a real thing.
Okay.
So it is real, but it's not quite the teleportation we see in sci-fi.
Right.
Quantum teleportation isn't about transporting matter. It's about transmitting information.
Okay, so remind me how that works. I know we touched on it before, but I think a refresher would be good.
Of course. So imagine you have two entangled particles. Let's call them A and B.
A and B.
And you separate them, maybe even across huge distances. Now you take a third particle, C.
C.
Okay. You entangle it with particle A. By doing a special measurement on A and C, you can instantly send the quantum state of C to B, even if they're miles apart.
So the information, it just like jumps from C to B. Even though there's no physical connection between them, it's like they're communicating through some, invisible channel.
Yeah, that's a great way to picture it. And remember, no physical matter is traveling between them.
No.
It's just the information, that quantum state that's being teleported.
So we're not beaming ourselves up to spaceships anytime soon.
Not yet.
But what are the real-world uses for this kind of technology?
Well, the implications are huge, especially for communication and computing. Imagine a world where we can send information instantly, securely, without any data loss.
Wow.
Quantum teleportation could be the key to making these ultra-secure communication networks where any attempt to, intercept the message would be detected right away.
Interesting.
It could also be crucial for connecting quantum computers that are far apart, leading to a global quantum internet.
A quantum internet.
Yeah.
That just sounds incredibly futuristic.
It is. It's pretty amazing.
It's exciting to think about the possibilities, but I also wonder, about the potential downsides. Instant, unhackable communication, they could have unexpected consequences, good and bad. How do we make sure this kind of power is used ethically and responsibly?
That's the key question, right? It's not just about the technology itself, it's about the social and ethical implications.
Yeah.
So we need to think about the impact on privacy, the possibility of making existing inequalities worse, and the need for strong safeguards to prevent misuse. It's a reminder that scientific progress has to go hand in hand with ethical thinking and responsible development.
It's a lot to think about, and it feels like we're just scratching the surface of what's possible with this quantum technology.
We are.
It's both exciting and a little daunting, to be honest.
I agree. But that's what makes it such a fascinating area to explore, It's a journey that really forces us to confront the limits of our understanding, to imagine new possibilities, and to wrestle with those deep questions about the nature of reality and our place in it.
We've covered a lot of ground in this deep dive, from how entangled particles act to the crazy implications of parallel universes.
I know, it's a lot.
We've talked about the potential of quantum computing and teleportation to reshape the world, and those ethical challenges that come along with that.
Yeah.
But there's one more piece to this puzzle that I want to explore. We've talked a lot about the science, the technology, the good, the bad, the philosophy. But I think it's important to remember the sense of wonder that comes with thinking about these ideas.
Absolutely.
The awe.
There's something really humbling about recognizing that we're part of a universe that works in ways we may never fully understand.
Yeah.
Quantum entanglement is like the perfect example of that.
Right.
It shows us that reality is way stranger and more interconnected than we usually think, and it kind of invites us to embrace that mystery.
It's like we're constantly peeling back layers of reality.
Right.
And with each new discovery, we're left with more questions than answers. But that's what makes it so exciting, right? The pursuit of knowledge. The thrill of the unknown, that sense of wonder when you're exploring the vastness of the universe.
That's exactly it, It's a reminder that even with all our scientific advancements, there's still that sense of mystery and awe. It keeps us wanting more, keeps us asking questions, keeps us pushing the boundaries of what we know.
Well said.
Yeah.
And I think that sense of wonder is what drives us forward, both individually and as a species,
It does.
It's what inspires us to explore, to learn, and to build a better future.
It's amazing to think about how much we've learned about the universe, but also how much is still out there,
That is.
It's like we're at the edge of this giant ocean, and quantum entanglement, it's just the tip of the iceberg.
That's a great way to put it.
Yeah.
It really highlights that this isn't just about the science itself. It's about what it tells us about our place in the universe, what it means to be human,
Exactly. So we've explored, the strange world of quantum entanglement, from the basics to these mind-blowing implications.
Yeah.
Parallel universes, quantum computing, the ethical stuff, even the connection to consciousness. It's a lot to take in. It really is. But, it's this kind of exploration that pushes us, it expands human knowledge and helps us understand, where we fit into this crazy universe.
Okay, so before we wrap up this deep dive, one last question.
Okay.
We've talked about the science, the technology, the ethics, the philosophy. But what does it all actually mean for us, for everyday people? Why should we care about quantum entanglement or parallel universes?
That's a great question. On a practical level, quantum technologies, they're already having an impact, right?
Yeah.
More powerful computers, potential medical breakthroughs, things that could actually save lives. And that influence is only going to grow.
So this isn't just theoretical. It really affects how we live and work.
Exactly. It's real world stuff.
Yeah.
But even beyond those practical applications, there's something really inspiring about entanglement, don't you think?
I do, yeah.
It shows us that the universe is more interconnected, more mysterious than we ever thought possible. It challenges our ideas about reality. It makes us think about possibilities we might have thought were just science fiction.
Like it gives us a new way of seeing things.
Yeah, a new lens, one that reveals hidden connections, that makes us think beyond our limited view.
And that change in perspective, that openness to the unknown, that's powerful stuff.
It is. It can help us appreciate the universe more, see ourselves as part of something bigger, and approach life with more curiosity and wonder.
That's a great way to put it. And I think that sense of wonder is really what makes this journey of discovery so rewarding. It's not just about getting answers.
Right.
It's about asking the right questions, being open to the idea that the universe might surprise us in ways we can't even imagine.
Absolutely. And that's what makes quantum entanglement so fascinating. It reminds us that we're just at the beginning,
Yeah.
There's so much more to explore.
Well, thank you for taking us on this journey. It's been pretty mind-blowing.
It's been my pleasure. I always love talking about this stuff.
And to all our listeners, thanks for joining us for this deep dive into the wild world of quantum entanglement. Remember, the universe is full of mysteries, so keep exploring, keep asking questions, and never lose that sense of awe. We'll see you next time.